Today we're going to talk about combining random variables so that unlike what we did yesterday where we were talking about adding or subtracting a constant or multiplying or dividing a constant by a set of random variables, today we're going to talk about what happens if we have two random variables that we either want to add or subtract. And we'll see a little example at the end of today's lesson that's a practical example about why you might want to add or subtract random variables. But let's start with a simple example and see if we can figure out what happens to the mean and standard deviation if we combine random variables. So let's start with a pretty simple example. We have two random variables and with tables here, both x and y. And I'd like for you to pause the video and find the mean, standard deviation, and variance of x and y using your calculator. So hit pause here and find those. Okay, now that you've found them, this is what my calculator indicates that the mean and standard deviation should be. So it appears to me that the mean of the table x, the random variable x, is 7. The standard deviation of the random variable x was 2. So the variance of the random variable x would be 4. Remember that the variance is just the square of the standard deviation. For y, my calculator told me that the mean of y is 13. The standard deviation of y is 3. And the variance of y then would be 9. So remember that the variance is just the square of the standard deviation. Now let's see what happens if we create a new random variable by adding the random variables x and y. So we have a new table here of x plus y. Notice that x plus y are all the possible combinations of the sums of the terms in the random variable x and the random variable y. And we're assigning each of them an equal likelihood, a probability of 0.25. So if I enter this data into my calculator, again, I'm going to ask you to pause and practice entering the data into your calculator and asking the calculator to calculate the mean and the standard deviation. And when you do that, it turns out that the mean of x plus y turns out to be 20. The standard deviation of x plus y turns out to be 3.605. So that means that the variance of, that's not right, let's correct that notation. The variance of x plus y is 3.605 squared, which is 13. So it seems pretty straightforward to me that this is just the mean of the random variable x plus the mean of the random variable y. This is just the square of the standard deviation of the random variable x plus the square of the standard deviation of the random variable y. This is not just the sum of the two standard deviations, though. This is the square root of the variance. So in order to find my new standard deviation, I can't just take the standard deviation of x plus the standard deviation of y. Mathematically, that makes a lot of sense because I know that this expression here for the standard deviation is not the same as the square root of each part and then added. And sure enough, it's not the same mathematically or statistically. And so we need to, in order to find the standard deviation of the sum of two variables, we're going to back up into the variance of each of the random variables and then from there calculate the standard deviation. So these are the rules for the mean and standard deviation of the sum of random variables. So for random variables, x and y, If we add x plus y, the mean of the random variables x plus y is just the mean of the random variable x plus the mean of the random variable y. The standard deviation of x plus y is the square root of the standard deviation of x squared plus the standard deviation of y squared. This, I should have written the notation here, this we can note as the mean of x plus y. This we can note as the standard deviation of x plus y, and use our subscripts in that way to denote the new values that we found. Suppose we create a new random variable by subtracting y and x, so we have a new random variable y minus x. Let's now find the mean, standard deviation, and variance of y minus x. So I'm going to pause here for a minute. You hit pause on the video and calculate those with your calculator. I believe that you'll find that the mean of y minus x is equal to 6. That the variance of y minus x is equal to the variance of y 13, and the standard deviation of y minus x is the square root of 13, or 3.605. So we see that the mean of y minus x is the difference in the means of the variable y and the variable x. The standard deviation is the same as for y plus x, and the variance is the same as for y plus x. So we can write those rules as well. So if we want to find the sum or difference, then this is what we find. The mean of, and I'm going to write y minus x is the mean of y, subtract the mean of x for my two random variables. The variance of the two random variables is the variance of y minus x is the variance of y plus the variance of x. So the standard deviation of y minus x is the square root of the variance of y minus x, or the standard deviation of each of those quantities squared. So notice that the mean of y minus x, the difference, if I'm doing the difference of two random variables, then with the mean I subtract the means, but the standard deviation and variance of the two are the same because I'm squaring the quantities, so I end up adding the two variances, and the sign here in the standard deviation of y minus x is still addition. So let's do a little example. So we have two guys, Tom and George, playing golf, and their scores have the following distribution. Tom's scores follow a normal distribution with a mean of 110 and a standard deviation of 10. George's scores have a mean of 100 and a standard deviation of 8. So George is a better golfer than Tom. So what if we wanted to find the mean and standard deviation of the sum of Tom and George's scores? So that would just be the mean of Tom plus George. That's just the mean of Tom plus the mean of George. Tom's mean is 110. George's mean is 100. The sum of their means is 210. If I wanted to find the standard deviation of Tom plus George, then I'm going to do the square root of the standard deviation of of standard deviation of Tom squared plus the standard deviation of George squared. So that'll be the square root of 10 squared plus 8 squared. So that's the square root of 164, which is 12.806. Then the next question is actually more interesting. What is the probability that on any given day the sum of Tom and George's scores will be greater than 220? So if they were playing in a tournament together, they might care how frequently they were going to end up with a score greater than 220. So let's think about what we're doing. We know that Tom and George are normally distributed, so the sum of Tom and George is also normally distributed. We want to figure out when the sum of their scores, we have this new normal curve now with a mean of 210 and a standard deviation of 12.806 that represents the sum of their scores. And we want to figure out, my means here at 210, we want to figure out there's 220, when will they be greater than 220? And so I'm looking for the probability that Tom plus George is greater than 220. That's equivalent to looking for the probability that their z-score is greater than 220 subtract 210 over 12.806, or the probability that their z-score is greater than, that's 10 divided by 12.806, 0.7808. Then I'm going to use, I have my z-score and I'm looking for the probability, so I need to use my normal CDF function, my calculator. So, and I'm looking for my z-value to be greater than 0.7808, so I want my lower boundary to be that 0.7808. I want my upper boundary to be, say, 100. My mean for my z-scores is always 0, and my standard deviation for my z-scores is always 1. And when I enter that into the calculator, I see that my 0.2175. So there's a 21.75% probability that Tom and George's scores, the sum of Tom and George's scores, Tom plus George, I'm out of space here, is greater than 220. So not great. Just about a 20% probability. Okay, another example, looking at the difference in Tom and George's scores, Tom minus George. So the mean of Tom minus George is just the mean of Tom minus the mean of George. The mean of Tom is 110, subtract 100 for George is 10. The standard deviation of Tom minus George is going to be the exact same as the standard deviation of Tom plus George. It's the standard deviation of Tom squared plus the standard deviation of George squared. So that's 12.806. And then the second question here, what is the probability that Tom will beat George? Probably more interesting to Tom and George. That's the equivalent of finding Tom minus George to be less than 0. So that is, Tom beating George means that Tom has to be less than George if you play golf. So if I subtract George over, Tom minus George has to be less than 0. So I have the same normal distribution that I had, new normal distribution that I had before. My mean is 10. My standard deviation is 12.806. So there's 10. I want Tom minus George to be less than 0. So that's down here somewhere, right? So the probability that Tom minus George is less than 0 is equal to the probability that we have a z-score less than 10, 0 subtract 10 divided by 12.806. So I'm looking for the probability of a z that is z is less than negative 0.7809. So again, I'm using my normal CDF function, except this time I want my value to be less than, so I want my lower value to be negative 100 perhaps. My upper to be my negative 0.7809. My mean is 0. My standard deviation is 1 for z-scores. And hopefully you don't have to do that on your calculator, but if you do, because we just did it, the same z-score value, we'll find that 21.74 is the probability. So there's a 21.74% chance that Tom will beat George on any given day. Okay, that's it for today. See you tomorrow.